A video shot in the auto component industry has been done to understand the best business practices followed or to follow in the industry. The manufacturing of spacer damper frame has been observed for a thorough understanding. The raw material passes through a series of processes in the shop floor, where it undergoes modifications at various levels to produce the frame to the customer requirement. The first stage is the verification of the test report of the incoming raw material and storing in the appropriate place. The raw material storage place has a strong influence on the overall lead time, and hence the place should have easy access to the processing areas. Traceability is a very important criterion in a manufacturing industry, given a calculable amount of time is spent in tracing the appropriate item in the storage area. This would increase the idle time of the machine and labor waiting for the material. Hence, color codes are assigned to every alloy used for melting. The purpose of the color codes is to allow for quick identification of raw material. This would also reduce possible human errors in differentiating the alloy through visual judgment. The organization follows a standard FIFO, first in first out stock rotation policy. This is an efficient way of rotating the stock, prioritizing the materials that moved in early. Additionally, the industry will have a track record of which batch of raw material was used at what point of time. This will help the industry to trace and identify issues or defects pertaining to raw materials. Stock rotation gives a realistic value of the inventory stock handled. It is also easier for the industries to switch over if there is a change in material composition by customer. This is particularly important for suppliers with limited customers. The employee reads the stock table and identifies the location of the raw material from the table. Then the corresponding location number is checked on the raw material bundle and loaded in the trolley. The employee is trained to handle heavy material safely by limiting to lift or carry only permissible weights allowed as per industrial standards. It is also ensured the location board is replaced on the bundle. The loaded trolley is safely moved to the melting area in the movement lanes. Melting of raw material. Prior to charging the raw materials, additives are added into the melt for degassing and fluxing. Degassing is usually necessary to reduce the amount of hydrogen dissolved in the liquid metal. If the hydrogen concentration in the metal is too high, the resulting casting will be porous as the hydrogen comes out of the solution as the aluminium cools and solidifies. Porosity often seriously deteriorates the mechanical properties of the metal. Dissolved gases are removed by one of the degassing techniques described above. A refining operation to remove entrapped oxides and inclusions is often necessary in aluminium alloys. These alloys easily form solid oxides called dross, which tend to remain suspended in the melt. Flux is a chemical substance, usually a base which combines with impurities to make a molten slag. The operator then safely stirs the metal for the additives to mix with the molten metal. Sufficient time must be allowed for the particles to float to the surface in the furnace and ladle, or they must be fluxed from the metal by stirring a reactive salt flux into the bath. The additives react with the impurities in the melt to form slag, which is removed to the slag tray next to the furnace. The raw material are then carried near the furnace to prepare for charging into the furnace. The die casting machine is switched on and we notice that ladle is lowered into the furnace to load the metal. The die lubricant is then manually sprayed in the die contours. The main purpose of applying a lubricant or coating is to create a partition between the metal and the die surface. They reduce the soldering tendency by preventing contact between melt and die. Lubricant also assists melt flow and casting relays. Single-armed robotic automation attachments is used to eject the cast product from the die, to carry melt from the furnace, and for spray lubricant oil in the die cavity to improve the casting productivity. These are the three main areas in the casting process where automation could effectively reduce the process time. The die is cleaned between each casting cycle and lubricated to reduce wear on the die to improve surface quality and to aid ejection. The lubricant is used to protect the molten metal from the relatively cool and conductive surface of the mold. A refractory coating in the form of slurry is sprayed or brushed onto the mold cavity, riser and gate and runner surfaces. French chalk or calcium carbonate suspended in sodium silicate binder is commonly used as a coating for aluminium castings. Chills are pieces of copper, brass or aluminium and are inserted into the mold's inner surface. A chill is commonly used to promote directional solidification. The ejected parts are then fettled manually, which usually involves a tumbling of the shots, with a small hedge hammer for separating the scrap, which includes the gate, runners, sprues and flash from the shot. This is employed if gates are thin and easily broken. In case of large parts, this is often done using a special trim die in a power press or hydraulic press. Other methods of shaking out include sawing and grinding. This is followed by inspection of the separated cast products, which is usually done by visual notice. The employee checks all the casting defects and dimensions and porosity as per control plan. If the parts are deemed okay, it is taken to the next stage of the process plan, which is fettling. Else, they are marked as defected and sent for remelting. It has to be noted, reworking the casting increases the production costs and affects the organization's margins. Hence, right casting parameters have to be ensured and appropriate practices have to be followed in the shop floor to reduce the number of rejected parameters. The selected parts are carried to the fettling process in the trolley. The excess burrs caused in the casting are loaded in the vise for removal. The fettled parts are then loaded into shot blast machine. The castings are rolled in while forced with multiple stainless steel shots at high speeds to remove the irregularities on the part surface. This is a very efficient process as it tends to remove the irregularities in all contours of the part. The next stage is to check all the casting defects and dimensions as per product report. The inspection process is repeated again. Where the parts match the dimensions, it is marked OK and placed in the dispatch tray, else it is rejected and sent for melting. The rejected part is marked with a red mark and stored in melting bin. The accepted parts are carried to the accepting area with an accepted tag in the bin. From this area, the parts are packed in the customer's trays and moved to the complete product storage area. The product area is then ready for transportation to the customer site. The organization follows a management hierarchy and clearly defined roles for the staff and employees across the department. These are expressed in charts for clarity. The management notice board serves as a quick reference for the employees on important issues in appropriate directions.